Hello everyone. In this video, we're going to look into how to analyze a finite state machine, which is denoted as FSM here, using a D flip-flop and an SR flip-flop. So let's see here. On page 1, we have a finite state machine here, and which has a combinational logic circuit with an AND gate and an OR gate and a D flip-flop here. And we have a clock signal. So what we're required to do here is, for this input pattern P, Q and R, we are required to find what is the output in each and every case. The very first thing we need to do is we need to identify what type of flip-flop is it is. It is a rising edge. It is a rising edge flip-flop. So with the output changes when clock is changing from 0 to 1. That is one. And number two is we have to find out what is the logic function that is going to the input D here, which is the function f. Okay, I'm going to write it as function f. My f in terms of P, Q and R is what? P, Q plus R, right? So once we identify the function of the input D, all what we need to do is look into the D flip-flop output, right? So if you recall from the D flip-flop truth table, what we have is if D is 0, my output is going to be 0. If D is 1, my output is going to be 1. So that is the simple truth table for a D flip-flop. Now let's look in here. First thing, let's do one thing. We know that my f is going to be PQ plus R. So all what I'm going to do here in page 1 is, like, we have PQ and R, and from that can we find the value of f? Yes, PQ and R here it is going to be 0. Sorry, it's going to be 0, 1, and PQ and R is going to be 1. And if we at this point P is 1, Q is 0, it is 0, plus R is 1, R is 0, so it's going to go down to 0. Now come back here, and P is 0, Q is 0, so it's going to continue till this point. When my R is 1, automatically my output is going to be 1. Now when you come down here, it's going to be 0, 0, 0 and 0. This is my function f, which is going based upon your simple combination circuit function f equals PQR. I just draw the waveform here. Now Q, as you can see here, Q is going to be the same as input D when clock changes from 0 to 1, right? So based upon the truth table here, we know my f is going to D, right? F at time t is the same as D at time t, which will be available at Q at time t plus 1, right? At the next point here. So what we are saying here is my Q is initially 0. So now what type of flip-flop is it? It is a rising edge flip-flop. So my output changes when clock changes from 0 to 1. So which is, I'm marking the different points of when my clock is changing from 0 to 1. It is changing 4 times. So all what we need to do is evaluate Q at 4 times. At this point, what is my f? F is 1. At time 1, my f is 1. So my Q is changing to 1, remains there till the next time when clock is changing from 0 to 1. At this time, time 3, when clock is changing from 0 to 1, what is f? F is 0. So my output falls down to 0, stays there till the next time clock is changed from 0 to 1. At this time, what is my f? At time 5, my f is 1. So my output changes to 1, remains there till output 7. And output 7, when clock is changing from 0 to 1, what is my output f? Which is 0. So here. With this, you can complete your analyzing your finite state machine using a D flip-flop. Now let's do the same thing with an SR flip-flop. First thing, let's look into what type of flip-flop is it. It is, let's say it is a rising edge flip-flop. And number two, we need to find the function here, and we need to know what is the value it is going to S, which I'm going to call as wire 1, and what is the value going to R, which is wire 2. Now, and we need to write the function for Z as well. Let's come to that in a minute. Let's write down wire 1. Wire 1 is what? X times Y, and wire 2 is X bar, right? So we have function for wire 1 and wire 2. So what I'm going to do now is I'm just going to draw the output for wire 1. Wire 1 is XY, so my output is going to be 0, 0, 0, 0, 0. It is going to be 0 all throughout. My wire 1 is 0 all the time. Now let's look at wire 2. Wire 2 is X bar. So if X is 1, Y2 is going to be 0. So I'm just going to take it, flip my wire 2, so we have wire 1 and wire 2, and now let's look into how to do the truth table for the SR flip-flop. Let's come down here for a minute. So we have S, we have R, we have Q. So if you recall, 0, 0, 0, 1, 1, 0, 1, 1 for 4 different states. My Q is going to be the previous value, and if it's 0, 1, my output is going to be 0, 1, 0 output is 1, 1, 1 is not valid. Now based upon that, let's see here. My Q initially it is 0, and since it is rising edge triggered, all what we look into is the time when my clock changes from 0 to 1, 0 to 1, 0 to 1, 0 to 1. It is changing at time 1, 3, 5, and 7. So all what we need to do here is look into the value of wire 1 and wire 2, which is my wire 1 is going to my set, wire 2 is going to my reset, right? So considering wire 1 as S, considering wire 2 as reset, compute your output Q. Q here, let's see here. My initial it is 0, 0, my S and R are 0 and 1. So when R is 1, my output is going to be 0 till the next time. Come down here. Now at this time, my S is 0, R is 0. So what happens? My output is going to remain the same here till the next time. When it comes down to here, my S is 0, R is 1, so my output would be the same till the next time. Here, S is 0, R is 0, so retain the previous value. Continue there till the next point. So overall, my output Q at any given point of time, my output Q is always going to be 0. So there is one other function here, one other output here, Z. We need to find the function for Z. My Z, if you recall here, that is going to be Y plus Q, right? So we have Y and we have Q. So based upon this, all what we need to do here is look into Q, look into Y at any given time, and just write the output. My Z is going to be, since Q is always 0, we can write Z as Y plus 0 becomes nothing but Y, right? So my Z is going to be nothing but Y, so I'm just going to draw Y exactly as is to state that my design is complete. With this, we analyzed a finite state machine in terms of finding the logic functions, in terms of capturing what is the output for any given input combination. With this, I will stop and we'll talk more about this during class. Thank you.